All right, welcome to The Explainer. Today we're talking about someone truly fascinating, Stanford immunologist Dr. Garry Nolan. And what's so incredible is how he applies the exact same rigorous scientific mindset to two worlds that could not be more different: the microscopic battle against cancer and the vast, mysterious cosmos. And this quote: "This is the key to everything. For a true scientist, the important stuff isn't the data that confirms what you already think you know. Nope. It's the weird stuff, the anomaly, the outlier that breaks the whole model. Because that's where real discovery begins." So, to really get what makes Dr. Nolan's approach so unique, we've got to start with his day job, fighting cancer at Stanford University. This is the known battlefield. He talks about the relationship between cancer and our immune system as this really intricate, complicated dance. I mean, your body is actually spotting and taking out rogue cancer cells every single day. But every now and then, a tumor learns the steps. It learns how to deceive the immune system and not just hide from it, but actually trick it into helping it grow. So, how does this trick actually work? Well, think of it like this. Your healthy cells are constantly showing a kind of ID badge to the immune system, basically saying, hey, I belong here, all good. Cancer, though, it learns how to shut that system down. It just hides its ID, and poof, it becomes invisible to your body's defenses. What's really interesting is that Nolan doesn't see cancer as some kind of advanced progression. He actually sees it as a devolution. It's like there's this ancient contract between all our cells to work together, and cancer is what happens when one cell just breaks that contract. It reverts back to this primitive, chaotic state where all that matters is itself. Okay, so to understand this incredibly complex dance, scientists knew they needed to see more, a lot more. They needed way more information. For years and years, the technology was pretty limited. Immunologists could only look at about 3 protein markers on a cell at the same time. That's like trying to understand a massive city by only looking at 3 street signs. It's just not enough. But then, new technology that came out of Nolan's lab just blew the doors wide open. Suddenly, they could see 50 or more proteins at once. This gave them a complete panoramic view of what was happening in that cellular neighborhood. But, this incredible leap forward created a totally new problem, a huge one. Scientists went from being starved for data to absolutely drowning in it. As Dr. Nolan himself put it, humanity had kind of backed itself into a corner with way more information than any human could possibly interpret. So what do? How do you find a tiny, meaningful needle in that continent-sized haystack of data? Well, you build a better scientist. And that's exactly what Dr. Nolan calls his team's solution. It's an agentic AI. This isn't just a calculator. It's an AI that actively asks questions and comes up with its own ideas. It's literally like having an immunologist scientist in a box, doing things no human team could ever dream of. Get this. This AI can read the entire library of immunological science. We're talking 22 million papers. Then analyze a patient's raw cell data and spit out a whole network of possible interactions and new ideas in a matter of hours. Not months, hours. This is a complete game changer for the speed of science. So, with these incredibly powerful tools, Nolan was ready to take on the most complex diseases known to man. But then, he got a very, very different kind of phone call. And this is the pivot point. This is the moment where the journey takes a sharp turn into some very different and much, much stranger territory. It all started with this tiny, strange mummy found in the Atacama Desert. After Nolan published his work proving it was actually a human with some really extreme genetic mutations, the government came knocking. Seriously. People from the CIA and an aerospace company asked him to point his powerful data analysis skills at a new set of problems. First, on these strange health incidents, and eventually on materials from alleged UAP events. So what happens when you point these world-class, state-of-the-art analytical tools at a piece of evidence that is truly bizarre? Well, you get data that is way, way off the curve. Nolan's team got their hands on a metal fragment from an alleged event in Ubatuba, Brazil, back in 1957. And the really weird part was its magnesium. See, anywhere in our solar system, magnesium has different forms, called isotopes, and they always show up in a stable, predictable ratio. It's like a fingerprint. But this sample, its ratios were just completely wrong. So you gotta ask, right, what would it take to create a ratio like that? Well, physicists at Stanford actually calculated it, and the answer is just mind-blowing.
You would have to expose the material to the same amount of neutron energy as an atomic bomb every few seconds for 900 years. Now, that's not proof it's from another planet or anything like that, but what it is proof of is a process, a technology that is just wildly beyond anything we currently understand.
And that brings us right back to that core idea from the beginning. From the tiny microscopic dance of a cancer cell to a weird piece of metal with an impossible history, the method is exactly the same. You don't ignore the anomaly. You don't dismiss the data that doesn't fit. You study it, because that's where the next big breakthrough is hiding. So that leaves us with one final big question to think about. We've seen how chasing anomalies in biology, that data off the curve, is leading to cures we once thought were totally impossible. So just imagine, what might we discover if we apply that same relentless curiosity to the anomalies that seem to defy our very understanding of reality?